Okay, so today we're going to talk about handover techniques for 4G network in UTHM. So, in March 2008, the International Telecommunication Union Radio Communication Sector (ITUR) specified a set of requirements for 4G standards, named the International Mobile Telecommunications Advanced IMT Advanced Specification. So they set peak speed requirements for 4G service, which is at 100 megabyte per second. For high mobility communication, the speed is 1 gigabyte per second. For low mobility, is below 1 gigabyte per second. So as you can see, the difference between 3G and 4G, the speed from the speed 4G standard is 20 megabyte per second to 100 megabyte per second. For 3G, it's only 384 kilobyte to 2 megabyte, while the frequency band is dependent on country, and 4G is high frequency band, which is 2 to 8 gigahertz, and the bandwidth, as you can see, it's 100 megahertz or more. So everything. I want to say about the access technologies. So for 3G, we use WCDMA, while 4G now is using OFDM and MCCDMA. So handover, what is handover? So handover can be defined as a change in channel of the ongoing connection in terms of time slot, spreading code. So this enables mobile terminals to maintain connectivity when moving between cells, systems, frequency, and others. The handovers could be vertical, inter-technology, or horizontal, intra-technology. So, methodology.
Okay, for the methodology, we have tested this experiment on G3 building blocks on 4-level floor, which is ground floor, first floor, second floor, and third floor. And every floor has 10 points locations, and we use network cell info light for calculation the system, and open signal mobile application for the calculation of data speed. Okay, for the wavelength calculation, we use this formula, lambda equals C over F. C is the speed of light in free space, and F is the frequency in hertz, and lambda is the wavelength of the signal. After we get the lambda, we put into the freeze formula to calculate the free space propagation loss by using this formula. PR is power receiver, and PT is power transmitter, GT is gain transmitter, GR is gain receiver, lambda is we get from previous formula, divide by 4 pi squared d squared times L, and we get in watt. After we get in watt, we change from watt to dBm by using this formula, which is power received in dBm equal to 10 log power received divided by 1 milli. And then the Okumura model, we use this formula to get the result. LF is the free space propagation path loss, AMU is median attenuation relative to free space, GHTE is base station antenna height, and GHRE is mobile antenna height. G area is gain due to type of environment. The GHTE we can get by using this formula, 20 log HTE, height of the transmitter, divided by 200, and the gain of the receiver we can get by 20 log height of the receiver from ground, divided by 3. And this is to get the the median attenuation AMU. By using this graph, we can find the frequency of the signal, and the distance in kilometer, and we can search for the value ANU. Okay, after we obtain the data is used to calculate handoff value. Graph of handoff measurement can be made from collected data and also the graph of rate over location. Location is from the same building but on different level and have 10 different points.
Okay, this is for the result and the analysis. First of all, we need to know what is the frequency of the telco we use. In this experiment, we use Celcom as a services to find the power receive, which has a frequency of 871.5 MHz with a gain transmitter about 10 dB, power transmitter about 40 watt, gain receiver about 2 dB, and the height of the transmitter was 30 meter, and the height from the receiver at ground floor 0.5, and the height of the receiver first floor is 5 meter, and the height of the receiver at second floor is 10 meter, and the highest level of this in this experiment was third floor, which is 15 meters. So this is the result from the result we got from the reading from the ground floor, and it tabulate inside this table. Each floor we have 10 point, so we calculate each point by using the apps. So this is the signal strength of the first floor, and the second floor and third floor. After calculating all the after measuring the signal strength of each floor, we come up with the power receive graph based on the mean value of the each floor, so that we can see that the power received on the third floor was higher than the power received on the ground floor. This happened due to the height of the location was nearly the same height with the antenna with the transmitter height, so there is no loss of sight during the measurement. So this is the data speed from each floor. We can see that the download speed and the upload speed was plotted inside the data speed versus flow graph. We can see that the lowest download speed was on the second floor. This is because the concentration of the user was very high on the second floor. Actually, second floor and first floor, the concentration of the user was high, but on the second floor it's more higher than the first floor, because at the second floor there is a lot of class having at the time we measure the measurement inside the G3 building. So the faster the speed was on the third floor, which is we got 10.95 Mbps. But the upload speed dropped on the third floor, which is 2.8. So this is the comparison of the measured and the theoretical value from the power received on the ground floor. The measurement power received was negative 1.2.1, and the first floor negative 102.5 dBm, and second floor was 100.4 dBm, and third floor is 36.4 dBm. So from the calculation we got a slightly different value to the theoretical value, maybe due to the losses and partition inside the building, such as the wall and others material that can block the signal and can reduce the strength of the signal. Okay, we also calculate the free space loss and Okumura pass loss by using a previous formula, and we got this type of value inside this table. Okay, another experiment we performed was the hand-off experiment. Okay, the objective of this experiment was to find out the hand-off absence inside the UTHM. First of all, we need to determine two type of base station. So the first base station was at G2 complex on the complex FKMP, and another base station was at FTV building. So the distance from these two base station was 2 km, and inside the 2 km we assign 10 exact location, which is each point we calculate the strength of the signal. So this is the measurement graph of the signal strength. As we can see, from point 1 to point 10, point 1 was near to the first base station, which is at G2, and the point 10 is nearly at the base station, second base station on FPTP building, where we can see that on the halfway of the points, which is the half of the distance of these two base station, we can see that the signal strength was slightly reduced a little bit until it reached the 0.5, which is negative 103 dBm. And then we find out that on the point C, the reading of the signal strength increased drastically until it reached to negative 66 on point 9. From this region, we can say that the changing of the base station is inside this measurement. Okay, so when point 1 to point 5, the receiver was far away from the first base station, and when the receiver near to the second base station, which is at we can see from point 6, the signal strength was increasing because the power receive was increasing due to the second base station. So we can conclude that the hand-off measurement graph, the hand-off measurement was occur in this experiment. So this is the data rate versus propagation. We can see that on the point 3 and until point 8, the download and upload speed is quite stable. Stable from point 3 to point 8. The speed, the average speed was 15 Mbps per second until when it reached to the point 9. The upload speed was getting higher than the previous point due to the base station, the second base station. So the near the receiver from the base station, we give a higher download and upload speed. We can see that the point 1 was from point 1 and 2 was near to the first base station. Okay. So at point 3 and point 8, there is a transition of the signal strength from base station 1 and base station 2. So as the conclusion from the collected data, the signal is strong when they near to the base station, and the hand-on measurement is calculated when the user is far away from the base station. And another conclusion is there is a need to develop a hand-off rerouting algorithm that can support level of network integration promises by the 4G wireless system. That's all from us. Thank you.